So we know from our previous videos that I have built a dashboard in Grafana where we have monitored certain metrics of the GPU that we can see over here, right? We have utilization, the power draw, temperature, and so on monitored from the hardware stack, right? But along the way, what we've done is that we've built an web UI for our VLLM. So the goal for today is to capture those VLLM related matrix. So, and then we will load test to the LLM as well. We'll capture the matrix during the load test, and then we'll observe how performance will change on the load. And before I go into that, I kind of wanted to do a recap of where we are so far. So what I have is I have a Kubernetes cluster. Inside my Kubernetes cluster, I have VLLM UI and the VLLM pod itself. So each of these pods have their respective service. I have a config map where I have declared my global variables, like which model I'm going to use, the max token size, and so on. And then I have my monitoring stack, which was installed using Helm chart. So that has all the Prometheus and Grafana related pods. So our dashboard so far monitors the hardware layer stack, right? The hardware stack of the GPU, but we are adding a few more things so that we can monitor our LLM related matrix as well. So all you have to do is once you have this repository, like I'll link it in this video as well, just clone it and then go into the VLLM container GPU. There's a Kubernetes setup directory, and then you have to run the runall.sh script. That script is enough to get everything up and running if you're working with a machine from Vast.ai. In my example now, I have one RTX 3060, 12 gigs of VRAM. So let's go ahead and get started. So if I run here kubectl get pods, you can see that I already ran the setup, right? So I have all of my pods running. Bear in mind the VLLM pod might take a while to run because it's just that, you know, the image size of VLLM is much larger, and then on top of that we have to download the model as well, right? So in my example right now I will be using Quen model. So we'll see that when we have the UI ready. And then actually the other thing I kind of wanted to talk about is that, so in my setup, right, like I have a desktop and then I have provisioned a machine in Vast.ai, which has a Kubernetes cluster for itself. And then there are a good few pods in that Kubernetes cluster, right? So I need to access, you know, the application inside those pods. And I can't do it directly from the Vast.ai node because it's just there's no GUI access in the Linux server there. So from my desktop, I have to enable some SSH tunnels to get that. It's not complicated. It's literally just one command and we'll have that setup ready. So that explains why I have to do the port forward and so on. Okay, and let's go ahead and get started. Okay, so I think once you have all of that set up, what we need to do is we need to go ahead and run the command kubectl get service, right? So we see we have the VLLM API and the VLLM UI service. We don't need to do anything because so let me pull this up here and so we don't need to do anything for the UI and the VLLM pod to communicate. That's already done as part of the setup, so I don't have to worry about the VLLM API service. So have a look here. I have VLLM-UI service on port 8080. So what I will do is I will enable port forward here and kubectl port forward for service. It's going to be VLLM-UI that is listening on port 8080. And then let's map it to port 8080 in my local machine as well. So what I'm saying here is that, you know, any traffic that comes to this node, the Vast.ai node, you can send that traffic to this particular service. And then any traffic that comes to this node on port 8080 can be sent to the service on port 8080. Oops, sorry. And then I actually want to run that in the background. So my bad, it's 1%. There we go. So it's running in the background. To confirm that, all we have to do is ss-tulnp and then grep. So it's kind of like socket, show me the ports, the listening ports, the UDP ports, TCP ports, and then so on. And then let's grep for 8080. Okay, so we see that we have an active connection in my local host, right? 127, that's my local server. We are listening on port 8080. Okay, so now to have access to the VLLM UI, what I need to do is I need to go to my Vast.ai and then see that connect option, copy that copy that here and then just open the session here, right? So what this says is that from my machine SSH to that particular IP address, and then map my local port 8080 to the remote localhost port 8080. That's how you have to connect to the vast.ai instance anyway. But once I do that, okay, leave that session open. So now it should work on, if I go to localhost 8080, it should work, right? Because what we have done so far is we've said that any connection that comes to the vast AI machine, transfer that to the service which is on VLM UI port 8080, and then we just did an SSH where we said that, yep, map port 8080 on my desktop to the localhost on port 8080. That's all that I need to do. So VLM chat UI, and there we go. So we have the UI here, and it says which model that we're working with at the moment. So it's Qwen 2.53 billion instruct model. So we have we have a window here where we can prompt and then we get a response. So let's check something like watch NVIDIA. Actually, let me just go yeah, watch dash n 0.5 NVIDIA dash SMI. So we see as of now that our utilization is 0, the fan is at 0, but the memory is preloaded because we know VLLM does this part, right? It kind of claims it beforehand so that it doesn't have to load everything, all the CUDA kernels into the memory again and again. So this is how we get faster response. So I can ask a prompt something like, give me what are the top 15, or actually top 10 tallest mountains in the world. Okay, so this is just a prompt, and then we will see the GPU utilization should go up. Oh, okay, I think I have to just run that again. Yeah, so we see the GPU utilization is going up because it's doing some inference, and then this is how we get the results back. So a couple of things here, right? It says how long it took, the number of completion token, prompt was 42, and then completion was 427. So the total token used for this operation is 469. Okay, so now we have this. Now what I want is I want to have a dashboard where I can monitor all of the requests that comes into my LLM, right? So to get that done, what we need to do first is we need to get the service that is responsible for our Grafana. So okay, for Prometheus Grafana. Okay, so it's on port 80, right? So this service is listening for traffic on port 80. Let me grab again. Let me grab just GOAFANA Grafana. So here, listening on port 80. So likewise, I need to do a port forward, right? So I'll do kubectl port forward. And then the service here is Prometheus-Grafana. Okay. Or actually, let me check. I should have this set up already as part of my installation, and then grep. So I'll do ss-tulnp and then grep for 80. Oh yeah, so I'm listening on port 80 already. I believe this is completed during the setup script. So in the run all.sh, I'm pretty sure I have let me check where exactly is it. Probably in run all.sh I have the port forward setup. It is done somewhere, I mean, if it's not done, then we just have to perform the exact same port forward on whatever port we want. So I believe it is done on port 3000. So let me have a look here. So if I open 3000 now, right? Oh, sorry. 3000. It shouldn't work, right? The reason it shouldn't work is because we haven't done the forward from my desktop to the vastai.node, right? So I need to do that first. So for me to do that, what I need to do is I need to go to my vastai, click on my connect options, copy that, and then just paste that here. After I paste it, all I have to do here is that map on my localhost 3000 to my remote machine on port 80. right? So once I have that tunnel active, now this should work. And there we go. We have the Grafana dashboard up and running. So I need to decode my password for the dashboard. So for that, we need to go kubectl get secrets -n monitoring, and then it's this secret that I want to talk to. I have to go kubectl -n monitoring get cc or secret, and then let me just get the output in. That's YAML monito or inc monitoring. Okay, so each time the password is changed, right? So for me to get the password, I have to check it from the YAML file, but remember it is decoded in Kubernetes by base64. It's the default decode, so we can encode it's encoded with base64 by default, and so we can decode it as well. So all I need to do is kubectl -n get the output in JSON path equals to. So this is going to be, let me just put this in that curly braces dot data dot admin admin dash password. So it should be that. So we get that. After I get that, I have to go base 64 dash decode, and then let me print it in a new line, and that's the password. Okay. And there we go. Yeah, so any secret, you know, it could be, for example, if I want to decode my username, just run this command here, kubectl -n to get the namespace, get the secret that you want. And then after that, the reason I prefer to see the output in YAML is so that I know for my JSON path, what am I following. So I go .data, so that's my first field, and then I have to go .admin password. So for example, if that was a secret that I wanted to decode, then I would go .metadata, .labels, whatever the, you know, the name of the secret is going to be. So anyways, now we are in a Grafana dashboard, right? So if I go to dashboards here, and then let me create a new dashboard. Let's import and the JSON file. Let me go up here, and then this is the JSON file that I want, and import. Okay, so we already have, you know, like I have, say, these things kind of defined beforehand, right? So the SM clock frequency, and then the free memory and GPU related metrics, right? So if you look here, the couple of new metrics that I've added is request latency, like how long does it take for a request to be served back, tokens per second, how many tokens are being generated or served, and then there's total tokens generated, right? So you know how many tokens got generated since this LLM is up, and then there is total tokens it received, and then the output it gave, and then there's a combination of all of that, and then there's a throughput, right? It's like how many tokens can it process per second. So these are the metrics that we have, and then all of these metrics are actually exposed in our code itself. So if you want to see and play around or expose more, what you have to do is just go to cd vllm UI, and then see this ui.py file here, and so this is where I'm exposing all of my metrics. So see, like request count, and then there's latency, and then there's tokens in, there's tokens out, and so on. So it's done in the code itself. So if you want to, like, you know, expose any further matrix, you can do it there, but that's just an example. That's where you would expose your token anyway in the application itself. And then for this to be seen in Grafana though, we have to apply the service monitor too, right? So if I go back here, vllm YAMLs, and then see that service monitor UI.yaml, we have to create that as well. So essentially what this is that, right, we need a service monitor that monitors a particular service, right? So let's go back here. So we need a service monitor, right, that monitors a particular service. In our case, it monitors our VLM UI service, and then any traffic it receives, it can send it to Prometheus, right? So this is a custom resource. This is a CRD by Prometheus Grafana itself. So this is how you would expose matrix from any particular service back to Grafana and Prometheus. So and even for our GPU stuff, we have a service monitor. For this as well, we have a service monitor. So any way you want to expose traffic in this setup through a service, you'll need a service monitor. But it's done easily enough. Like when you are in the YAMLs file, just run the kubectl apply -f dot, and then this will run all the YAML files that we have here to make all the pods and other stuff ready. So now what I want to do is I want to perform some load tests. So let's go to Python load test, right? So let me check Python load test. Okay, yeah, and let me go this. Okay, I think I need to install a couple of things here. All AIO HTTP. Pip. Install AIO HTTP. So yeah, I think in the meantime, what I can do is I can, what are the 10 tallest mountains in the world? What are the 100 tallest mountains in the world? So let's see, we should see some increased number of tokens. And the traffic is being sent. It's taking a while because, you know, it's a longer response. Okay, so it gave us the output in 512 tokens, took 11.7 seconds. If we go back to our dashboard, what we can see here is that this takes a while. Like, you know, there's a sub-second delay to pull the matrix back. There we go. So the tokens that was handled per second went up here, because when the VLM was not being used at all, when no one was talking to our LLM service, it was down to 0, but now it went back up to 10.2. The total token generated are flying up as well, and then we see the total token throughput. It's essentially 0 when no one is using our model, but when it goes up, we see the total tokens out per minute is 106, in per minute is 8.9. So you know, and then I think this is the request latency. So what does that say? So it took around 10 seconds to complete 50% of our requests, right? Because we can see that here as well. It took 11.7. The previous one took somewhere around that as well. So what I have here with my Python load test is essentially, let's go here, and then see there are like a bunch of 10 prompts here. And then among these 10 prompts, we run this prompt in a loop. So a lot of tokens are generated. And then that way we kind of, you know, see that how long it took for each request and so on to complete. And then we can see those matrix properly in our Grafana. So there we go. So the number of total requests we want to send, it depends on what kind of load we want to perform. So in my case, I have this medium load uncommented out. So I will be sending 50 requests, 10 at a time, and then it will randomly pick from this prompt pool here, right? So this is how we will be querying our LLM, kind of like real world setup, right? You'll have your LLM service, and then a lot of users will be interacting with it simultaneously. So let's go ahead and run this. Let's quit, and then Python 3, Python. Oh, I need to change the file. One Python load test to Python load test.py, and then Python 3 Python load test.py. Okay, so it's sending all of the requests. Let's keep sending some requests from our side as well. That's gone. And then let's have a look at the dashboard, right? So our Python script is running. And okay, so let's give it a few seconds. What we can do here as well is that actually I can go to here. I can go watch -n 0.5 NVIDIA. That's SMI. So this way I can see that my GPU utilization is at 97-96%. So we know that our LLM is actively using my GPU. So it just takes some time for the matrix to come here, because there are a lot of communication right before this matrix are pulled up here. So there we go. So our GPU temperature had started to climb up, and then our GPU utilization should shoot up in a moment as well. We see, there we go. So that did shoot up, and then the total number of tokens generated, we already generated 16,973 tokens. And then the total output was 15,422. The max token we generated so far is the throughput, right? We generated up to 3,100, right? 3,102 tokens per minute. And then most of our 50% of our requests are getting handled at less than 10 seconds. So it's at static 10 seconds now. The tokens generated per second at maximum was 290. And okay, so let's see here, 0%. Okay, so that request completed. I didn't send all the outputs to my standard output because I don't want to see the responses to all of those, right? But we just want to have a look at the matrix. So here it tells us the matrix as well. Total tokens for this operation was 19,796. Let's have a look here. It says 21,304 because this is inclusive of what I'm sending in the UI as well. But this is just for this operation, right? So if you notice the different numbers, it's because of that. And then average token per second, it took 20.38 per second. Average tokens per request was 395.9 tokens were used for each request. That's what it means, right? Latency matrix. Okay, so the maximum it took to answer one query was 58.032 seconds. Minimum was 2 seconds. And then, 50% of our request was handled in 26. 95% was done at 56 seconds. And then 99 was done in 58 seconds. The average is 28. And then we sent 50 requests. All of them were successful. So see, like, it really depends when you talk with an LLM on what kind of query are you sending, right? If you're asking a simple thing like what days today or how many days are in a week, it will take maybe really less amount of time, right? But if you're asking something complicated, then it's going to take a lot of time to give response to that. So in our case, for instance, right, let's have a look at the tokens we have. So explain REST API in 100 words. I think that's going to take more token and more inferencing than it might take to answer compare get an SVN. And we have describe the OSI model. Okay, so that's going to take some more tokens rather than maybe database indexing, right? So it really depends on what kind of queries we have. So let's run these stress tests one more time. So to do that, I will just go to my Python load test. Let me go to the bottom and then let's comment this operation here. So insert, and then hash it out, and then let's put it through a heavy load, right? So in this case, we will be sending 100 requests, maximum 20, and then let me put a prompt here that should not take long to complete. Let me go back up here and then just go open. Actually, let me put the thing here, and then let me just go. How many days are in a week? Days are there in a week. So something like this should not take long to complete, right? Because it's an easy enough answer. So go Python 3 Python load test.py, and let's see this NVIDIA-SMI. This is running in a watch command 2, and then it's taking all of the requests now. We see our GPU utilization is climbing up from 0 to almost 93, 95. My temperature is going up as well. So let's go back to our dashboard, right? So from the UI, we can send another query if we want. How many days in a week? So I can send that here. This will take some time, right? Because we see that our GPU is quite busy at the moment. But, well, there we go, actually. It took just 0.36 seconds. So it really depends on the nature of the request too. So let me send that again, 0.37, send it again, 0.36. So it's not that this is slow, right? It's that depends on the nature of the query. So going back to my dashboard, So let's observe things for a final time. There we go. We see tokens per second maximum in our previous iteration was 290 on medium load, but we can see we have potential to generate more tokens, which is 301. And there we go. Those numbers are climbing up as well. The total in and out is 38,000 tokens already. Our output is 34,514. That's the input. And our request latency is like that is run every 5 minutes, so you'll see that going up and down. And then we know our system matrix, our temperature is climbing up, and our utilization is maxed out, almost 96%. So the memory used, it's quite static for all PD8 because we know VLLM kind of consumes certain amount of memory. We've said that you can use up to 90% of the memory, so it's at 11.5 gigs constant. So that's why the free memory is constant as well. The token throughput is climbing up because now we are doing 100 requests rather than just 50 in our previous iterations. And it's going down because it's probably completed the task. There we go. Yeah. So this was our test for 100 queries. There we go, 100 queries, successful 100. And then it took 57.88 seconds to complete the test. And yeah, a bunch of matrix here. So yeah, I think, the goal for this video was this, right? So it's not just about serving an LLM. Once you serve an LLM, maybe these are the important metrics that we need to have a look at, right? If I have a service like this outside for my customers, then if I see that my tokens per second is, for instance, say, if it's dropping constant, if it's dropping down, then I need to know that, okay, is something going wrong? Like why, if my peak users can go up to 635, but now I suddenly am dropping to 200, then something is going wrong, right? My GPU is not giving me the same number of tokens that it does per second. How long is it taking for my average request to complete? Is it taking less than 10 seconds or so on, right? So that is an important metric. And then apart from that, how many tokens have I generated already so far? So something like this might be useful if you are billing your customer based on how many tokens they generate or so on, or even just for ourselves to see that, okay, how many tokens that we have generated so far. And then the throughput, obviously we need to know like the maximum number of tokens that my model and this particular GPU can handle in a certain period of time. So if I'm running this particular LLM in one RTX 3060 versus if I run the exact same thing in one H100 or A100, the big data center grade GPUs, right? Like the token throughput per second is gonna be way better than what I have here because it's just a better hardware. So I hope you guys learned something from this video, and thank you for listening. And actually, I kind of wanted to say that I want to think about the next direction that I'm moving forward. So far, we have kind of played around with how to host an local LLM in our own local setup, configured our Kubernetes, have all the monitoring stack and so on, right? So I don't want to go down the rabbit hole of just kind of fine-tuning these metrics. I want to find how can something like this be useful for me. So my plan for going forward is, right, so I mean, this is just a plan so far, but I hope to bring this in action. So what I'm thinking is I will use GCP as my cloud provider. So when I worked in Sheen, I have seen how an e-commerce application is run. So because I worked as a production engineer in Sheen as well. So I want to build my own e-commerce stack in GCP. So once we have all of those setups there, we already have our LLM in Vast AI, right? So let me go Vast AI, and then here we already have all of these things set up, right? We have a UI, we have all of our dashboards and so on. So my end goal is going to be that let me run an e-commerce app in my GCP platform in a Kubernetes cluster completely. After that, any request that comes into my let's say my e-commerce website, let's use this AI model to build some kind of recommendation system. So when my user logs into my website, we will use our AI model that we have in vast.ai and then recommend what the user can buy or what might sell better and things like that, right? So I think that would be a nice production use case of how we host LLMs locally and what kind of things to do. On top of that, run an e-commerce platform, which is generally run there outside, right? And then from that e-commerce platform, we'll leverage the use of AI. This could be anything, right? This could be maybe you have a gym and then you have a bunch of users visiting your gym, right? Everybody has that profile. You want to run it through that LLM and find out more things. You might have, say, a booking system for a hospital or a dental clinic, right? So your users have their accounts and profiles and so on. You can run it through the LLM and we can get the logic out. So it could be anything, the only reason I want to go e-commerce ways because the tech stack behind building e-commerce is massive and it's amazingly interesting. So I think I'll have a lot of fun doing this. And then the reason for choosing GCP as my cloud provider is because they have a lot of native like AI/ML integration in GCP is much better than other cloud providers, I think. So they have their tensor TPU units and so on. So down the line we can explore more about those things. And yeah, I think that's it for this video, and thank you for watching.